Hey everybody, this is Larry. This is me going Q4 of the bi-weekly contest 125. Find the maximum sum of node values. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one is very interesting. It reminds me a bit of one of those classic competitive program but I don't think this is that hard. I think this is just, I mean, I got a wrong answer because, if you watch the live portion, it is very sad. I just kind of confused myself in the last minute, and somehow it worked for the input cases. But yeah, but basically, this is a very tricky problem, I think, if you don't kind of think about it in the correct way. But the first thing to notice is that basically you have to make these operation, and the observation that you have to make is that what do these operations mean? Okay, so there are a couple of things, right? One is that it's an XOR operation. I'm going to take notes here for you. That's why I'm kind of putting it here. But so basically the first thing is that it's an XOR operation, and we're trying to maximize the sum, right? So what does that mean? When we're trying to maximize the sum, and we have XOR operations, then we can think about it in a greedy kind of way, right? Basically, the idea is that a sum, if you maximize the most significant bits that are ones, then it doesn't matter what the rest of in terms of binary digits, if you optimize the number of ones, then it doesn't matter, right? Yeah, for example, yeah. I mean, basically, that's pretty much it. So here, we maximize the sum when we maximize the number of ones in the most significant bit, right? Of course, this translates like if there's a tiebreaker, then you take the second most significant bit, etc. Kind of. And I say kind of in a reason. But the thing is that you can flip only the number k. So that means that for the first, or for the most significant digit in k, we will try to flip 0 to 1s as possible, right? And what does this mean? There are other implications of this, but this is the observation that we're trying to optimize. That's what I was thinking about in the contest, right? We try to flip the most zeros to ones as impossible. Makes sense. The smaller, least significant digits don't matter because it gets dominated by the most significant bit, right? Or digit or bit or whatever, right? Basically, the idea is that, okay, let's say you have, this is your number. If you kind of be able to flip this to 1, it doesn't matter if you flip the rest to 0, right? Because this is just, strictly speaking, bigger. That's basically the idea here. So this is the thing that we get from XOR, right? So these are the observations that I think about XOR, and after that I go, okay, well now let's think about the tree and the operation, right? So here you notice that you can only flip twice or two numbers at the same time, right? So this is a constraint. Can only flip two numbers at the same time, right? And only if they're next to each other, right? So then what does this mean? So it turns out that if you kind of spend a lot of time on it, or some time on it, I don't know if it's a lot of time, is that the tree doesn't actually matter. And what do I mean by that? Let me kind of pull up the visualization real quick. Right, let me copy it. Sorry, technology. So okay, just want to make sure. Oh, this is a little bit big. It doesn't really matter. But the idea here is that it turns out the tree structure doesn't matter. Why? Because because for whatever nodes that you want to do, there's a pathway. And what do I mean by that? Let's just say, as long as you do even number of nodes, let's just say you want to, you do the math and you go, okay, I want to optimize for flipping this one and this one, right? Then what happens? There's always a series of moves that allow you to do this because, for example, for this 2 and 4, maybe this is not a good graph to kind of demonstrate this, but you can just flip. You can flip this one and then this one and then this one again, so cancel this one out, and then this one, and then now you have your answer, right? So it turns out that, you could kind of, I'm not going to show you a billion examples, but with this idea, I hope that you can kind of, construct graphs and play with yourself to find that for every even number of nodes, you can do this operation, right? So yeah, so here, it turns out the tree graph structure doesn't matter. You can flip any even number of nodes. So that's basically the key point. And from that's all I needed. And this is how I kind of come up with the answer. And this is my code, and we'll go over it. We'll go over the code. For example, here we start by every bit. And let me annotate this. Okay. Start by the most significant bit. This is the most significant one in K, right? This is basically the biggest 1K. And then here I wish I wrote this better because that's how I got wrong answers, that I made a silly mistake. But yeah, count the number of zeros in the ith bit, right? So that's basically what this is saying. Count the number of things that have zeros, and basically, yeah. And I kind of did this in the other way. Maybe you could have done it in a different way. I don't know, right? But basically, this is saying, okay, now flip all of them from zeros to ones. So yeah, so for all the ones that has for that digit 0, we flip it to 1. We also have to flip all the other bits, so we XOR the K with for this one. Yeah, but as I said, it will give you a bigger number, and then kind of we just sum up the total, which is what that problem is asking. So the thing is that, as we said, we can only flip even number of these. So this is basically what happens, and I kind of wrote this in a funky way, but yeah, if it's even, then we're done, right? Because you can only get worse answer by removing stuff. But if you have an odd number, then basically you have to unflip one of them, and that's basically what this code does. It unflips this, and basically do the math for what happens when we unflip this one, and then we take the best out of all of these. Yeah, as you can see, this is, this takes only a loop of 32, which is the number of bits. So maybe B if you want to keep track of bit over B iterations. And then here you just do, this is O of N, O of N, O of N. So this is 3 times N, or O of 3 times N, or O of N. So this is O of N times B. And that's your time complexity. And that's pretty much it. Yeah, and you can do this in constant time. Constant space. Sorry. Yeah, you can do this in linear time, or O of N times B time, and O of B space, if you will, if you want to keep it in the same notation. I know that I did this in place, but you don't even actually have to do it, right? You could just write, like an if-else statement and just sum it up in that way, and then here, But yeah, that's pretty much it. The observations are kind of cute and interesting, but yeah, that's all I have for this one. Let me know what you think, and you could watch me solve it live in contest next, and you could see where I made that mistake. As I was saying in the thing, I was so focused on the special case that I forgot to mentally check the base case, and I just kind of rushed it because some of it is because I spent so much time on Q3 that I rushed myself a little bit on Q4, and I made a silly mistake. So yeah. That's all I have for this one. Let me know what you think. And yeah, you could watch me solve it live in the contest. Now, we'll see. Oh, there we go. All right. Focus. I misread that one so hard. Focus, another tree bomb. And -1, you have edges and k on a node. The sum of the value of tree nodes to be maximum. We have k. Zero, 2. I'm too slow. I don't know. Alright, let's at least make out the list. Wait, do I do it this way? I don't know if I should just create a tree, but how do I do it? So you're given k and you're given some numbers. So basically you're saying, does this one? I don't know that I know how to do that. Okay, let's see. Okay, I mean, how can we be greedy? Alright, I need to use the bathroom for a second. I want to think about this on my head. People seem to know how to do this one, but I don't really. What does this mean? That means that an even number of things. I have to choose the even one, right? Okay, so we have to choose an even number of k things. And yeah, the edges don't actually matter, we just have to choose an even number of them. that means that if they're even number, then you just tick all of them at every node. And if they're odd number of them, you just choose one not to do it. Right? Okay, fine. Is that true? I think that's true. Okay, fine. Oh, if it's odd number. No, wait, is that true? You greedily do all of them. Yeah, because it's in greedy. Yeah, okay, fine. Okay, if there's odd number of them, then we do one back, right? Okay, maybe that's true. I don't know if this is true. If it's 0, then what happens? If it's 0, we continue, I guess. Is that true? If it is 0, no, it doesn't matter if it's 0. Okay, then fine. I'm about to flip one of these back. Minus j plus otherwise we don't do anything. K is at least 1, so I think this should be good, but 8, 13, 42. 42 is fine. 13 is wrong. K is 7. 6 and 7. Oh, this is not right. Whoops. Six, 9, 42. YOLO. Huh. How did I do better than the right answer? Alright, let's see. I thought that might be it, but apparently not. A lot of people got this one, so I'm kind of not doing so well. Did I do this right? It looks right. How do I even debug this one though? Am I wrong in my assumption? Maybe I'm wrong in my assumption. Can I not propagate? No, I should be right, but okay, let's see. So this is too. Okay. This is not true. Oh, dummy. I don't know why I wrote it that way. I try to be too slick. with that one. With the coding, because I got it. I had the idea, but I think I confused myself the way that I wrote it, because I was just like, oh, remember this case, and I remembered this case, and I forgot about the base case. Yeah, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Leave a comment. Stay good, stay healthy to your mental health. I'll see y'all later. I'll see you later and take care. Bye bye.